Well, good afternoon, everyone, and welcome to today's live astronomy program. My name is Justin, one of the astronomers here at the Science Museum of Virginia. Happy to be your host today. Always a pleasure to have an audience in these times. Now, if you have watched some of our previous episodes, welcome back. Happy to have you here again. If this is your first time tuning in, welcome to the show. This is, by my count, the 16th episode we have done this summer, every Thursday afternoon, live astronomy right here on Facebook, and looking to do it a few more weeks at least. The museum is opening its doors, members in the building right now, but I'm going to stay with you here on Facebook at least through the end of September, so even more to come. Now, for today's show, I was looking ahead on our calendar, and I see that there's a lunch break science next week that is all about volcanoes on Venus. So I thought it would be kind of fun to talk about volcanoes elsewhere in the solar system. I'll leave Venus for the presentation next week, but I'm going to have a little bit of fun talking about volcanoes all across the solar system. Now, before we start, I need to thank our sponsors for this series, Allianz Partners. Happy to have them on board. If you are able to watch this show on a nice big monitor, I recommend it because we are using software that is very similar to what we use in the dome here at the museum. It's planetarium software called Digistar 6, and can do some pretty cool stuff. So I would at least make this video full screen during the rest of the presentation. In fact, I'm going to do that. I am going to get us to our starting point and switch us over here to the view of Digistar. So, if we are going to talk about volcanoes in space, well, Venus is a great place to start. Way back at the beginning of this series, very beginning of the summer, I did a show that ran through all the terrestrial planets in the solar system and mentioned that Venus was, at some point in the past, very volcanically active. The entire surface of the planet may have been remade by volcanoes in the relatively recent past. But research continues to see how that volcanism may be continuing to shape the planet today. So that's what next week's talk at Lunch Break Science, Wednesday at noon, will be all about. My job today, I thought I would look through the rest of the solar system to see where else we might be able to find volcanoes and what they can tell us about the other worlds in our solar system. Now, I've got a lot of options available here. There are a lot of other worlds in the solar system, of course. These are the gas giants. Did a whole show about them as well. But if we're going to talk about volcanoes and other forms of geologic activity, we can't use those planets. Those are gas giants. They don't have solid surfaces. So we need to look at smaller worlds. There's Earth and Venus hiding out on the edge of your screen there. And of course, Earth has active volcanoes. We've got plate tectonics, the crust of our planet broken up into different pieces that move around. And then as we work our way down the line, that's just many, many worlds in the solar system looking smaller and smaller in size. But all these are worlds with solid surfaces. They're made of rock, ice, metals, minerals. So there's a chance that they have processes like the Earth and Venus. And indeed, on many of them, we do find evidence for things like volcanoes or tectonics of some sort, the crust moving around, and other general forms of geologic activity. So that's still a lot of worlds that we could explore today. So we won't see all of them. But I want to highlight a couple of very interesting worlds in the solar system. And, if you have questions about any of the others, feel free to leave your comments down in the comments below. And might be able to do something at the end of this show or return to any of them in a future episode. So let's get started. Let's see that lineup. I recognize a lot of those worlds. We got Earth and Venus, of course. That's too easy. Mars will go there for sure. Let's start with a familiar place, though. The Earth's closest neighbor in the solar system. Let's talk about volcanoes on the moon. Now, the moon certainly has a solid rocky surface, and we're pretty sure that some kind of geologic activity has helped shape the face of our moon. When you see the moon in the nighttime sky, you're probably used to seeing something sort of like this. Looking mostly at the near side of the moon there. I'll rotate around a little more for you. So we've got a surface that's broken up generally, we could say, into two different colors. There's a brighter, lighter gray, and there's a darker gray. Okay, so that's interesting, I guess. But when scientists really look carefully at a world like the moon, they can see more subtle differences than what might jump out at you. If you watched our very first episode here on Facebook, you may remember a new map that had just been released of the moon. It's an example of what's called a geologic map or a geomorphological map. I like to call it paint by numbers for scientists. And here's what it looks like for the moon. So here, each different color you see on the surface of the moon is telling you a little something about the rocks that are at that location. How they've been formed over time, and perhaps how old they are. Now here on the near side of the moon, you see a lot of pinks and reds. Those are regions that we call maria. Translates from Latin to seas. Now they aren't seas of liquid water like we have here on the Earth. There's no air on the moon, so you can't have liquid water. But we think it used to be molten rock. Now, in some of these areas, the story goes that a long time ago, as the moon was starting to cool from its formation, its crust had solidified. There was a barrage of large impacts that created big craters that then flooded with lava. So that's one form of volcanic activity. Kind of, but more recent data shows that something else may have been going on here. I'm going to back up just a little bit so we can get a slightly wider view of those volcanic plains, those maria here on the moon. And then I'm going to put a different colorful map here. This is the result of data collected by a pair of spacecraft named Grail that orbit around the moon, mapped the moon's gravitational field. A lot of times we just think of gravity in kind of large-scale terms, like how pretty much everywhere on the surface of the Earth humans feel about the same pull of gravity. But if you measure it very carefully, you'll see that gravity does fluctuate just slightly at different points on the surface of the Earth or any other world with a solid surface. So the Grail spacecraft orbit around the moon to measure these differences. That's the result of changes in density in the rocks or the thickness of the rocks in the moon's crust. And they did a little bit of math to find how these densities of these gravitational pulls are changing across the surface. And the result is the map you're looking at now. So what I want to point your eyes towards are those blue lines that sort of encircle the darker gray areas we can see with our eyes. Again, there's what the moon looks like to your eyes, those darker gray areas, smooth volcanic plains, and then here are the results of analysis of the moon's gravitational field. And, maybe your mind is already connecting some of those blue regions. You can almost imagine like a square that is kind of bounding that region of the moon's near side. Well, scientists saw that too, and they thought, wow, that looks a lot like another form of volcanism. What may have been happening here as the moon was cooling off from its formation, it would have actually shrunk just a little bit. And as it shrunk, we noticed that there are some ridges that formed on some parts of the moon, but those blue areas may have actually been vast rift valleys that opened up cracks in the crust of the moon, and those could have formed pipes, tunnels through which lava could have flown and helped fill those plains that we see on the near side of the moon. So rift valleys, the result of a form of plate tectonics here on the moon in its very early days. Now, I don't think any of that type of action is still happening here, but it's all recorded in the moon's rocks. Pretty interesting stuff right here on our closest neighbor. So if we can find interesting volcanic histories right next door, shouldn't be too hard to find volcanoes elsewhere. and certainly have a few other destinations in mind. Let's go to another relatively nearby spot. Well, let's check out Mars. Now, Mars is a little more well known for its volcanoes. We visited Mars in the very first episode here on Facebook as well, and would have talked generally about a couple of the features here on the surface. On our view here to the right, we have Valles Marineris, the Mariner Valley, and then we get into a volcanic region. There are three volcanoes kind of aligned there, and then a big one called Olympus Mons. We took a close look at Olympus Mons in that old episode. But all of these volcanoes are related to each other. If I put another colorful map here on Mars, don't worry, nothing as obscure as gravity gradients like we saw at the moon. This is just a topographic map. So here we're just looking at the relative height of the terrain on Mars. So in this map, the blues are the lowest terrain on the planet, and then as we go through reds, browns, all the way up to white, we're tracing the highest terrains on the planet. So those volcanoes are the four white mountains you see on this map. Olympus Mons kind of out here all on its own, but then these three all lined up with each other, and they're close to a very red and brown region on the surface of Mars. That whole region is called the Tharsis Plateau, and it appears to be what was a very active site of volcanic eruptions here on Mars. The volcanoes color-coded white here are the biggest, but there are many others that planetary scientists have been able to map out here. And as these volcanoes grew, it doesn't look like the crust of Mars was moving around all that much. Here on Earth, the crust does move around. That's why you get things like the Hawaiian Islands, right? There's one hot spot there, but the crust is moving across that hot spot. You get a chain of islands. Here, there's not a lot of plate tectonics. So we have this one gigantic volcanic plateau that results in most of the volcanic activity that ever happened on Mars. And if we zoom in here just a little bit, we can see some other associated features like well, more ridges and canyons that are aligned with each other. Up here to the north, you might just be able to pick out some lines going across the surface of Mars. It's another decent-sized volcano up there too. And of course, Valles Marineris probably opened up originally as a volcanic rift valley, similar to the ones that are now buried on the moon. So obviously volcanoes have played an important role here on Mars as well. But really, these are pretty easy targets to use to look for volcanic activity. It's certainly widespread here on the moon and Mars. To give you an idea of what we're working with here on Mars, here is the continental United States positioned over the Tharsis Plateau. So not only are those volcanoes big, this volcanic region covers a huge area of land. So that's pretty impressive. But you know, Earth, Moon, Mars, really in the early days, you know, they would have had similar features. They've followed similar trajectories, though Moon and Mars certainly a little bit different because of their smaller size. What if we looked even farther from the sun, so that the worlds we're looking at were made of different materials, maybe some smaller worlds, so that they have some different features? No, we're going to head out into the outer solar system, and we'll find some volcanoes out there too, but I'm going to give you a sense of scale, what we're going to be looking at. So in this view, that blue circle represents the size of the Earth, and these are the next 4 destinations that I have plotted out. So in order, we've got from left to right, we've got Ceres. That is a dwarf planet that is in the asteroid belt. Then we've got 2 moons of Jupiter. That's Europa and Io. And then a little tiny moon of Saturn named Enceladus. Now, despite the fact that there's most of 1 billion miles separating these worlds, and obviously very different in size, they all have signs of geologic activity. In most cases, we think that geologic activity on worlds like the Earth, Moon, and Mars are driven by internal heat, either from the formation of the world itself or radioactive elements inside the worlds. Not here in the outer solar system, and with smaller worlds, we have to look for some different explanations, and the volcanoes can look slightly different. So let's start at Ceres. If you watched a few weeks ago, we visited Ceres, and I talked about this crater with the bright white spots in it. That crater is named Akator, and those spots seem to trace a history of cryovolcanism, so low temperature volcanoes. We're not talking about molten rock here. Now we've got a mixture of water, salt, and perhaps the other minerals that make up the rocks on Ceres. It's basically a brine that may be stored underground here on Ceres, either in liquid form or as ice. And originally the thinking was that these bright spots were the result of old eruptions triggered by the impact that formed this crater. All the water escapes, leaves the salt that was mixed up in the brine behind. The results I covered a couple of weeks ago show that some of that salt is very new. There's still some water locked up in those minerals, so it may be ongoing volcanic activity. But there's another sign of geologic activity here on Ceres. Let's see if I can track it down. Should be in this general neighborhood. Instead of looking at the bottom of a crater, I'm going to try and find the largest mountain on Ceres. Shouldn't be too hard to pick out. It rises about 2.5 miles above the surrounding terrain. That's some 4,000 meters. Its name is Ahuna Mons, and I think I see it here, straight ahead. Now, this mountain is not just a regular pile of rocks that has a nice sharp peak. This one has a relatively flat top. And there's also some signs of bright material in this region, may even be flowing down the sides of Ahuna Mons at times. What this may be is a feature similar to lava domes that can form here on the Earth. But again, because we're dealing with cryovolcanism, low temperature volcanoes, it's just a place where the brine is rising up from inside Ceres, and not a full eruption like we can see on more explosive volcanoes here on the Earth, but still causing this mound to rise up on Ceres above the surrounding terrain. Ahuna Mons is the tallest mound of its kind here on Ceres, but it's not alone. Planetary scientists working with the Dawn mission have mapped out dozens of these features. So I'm going to put markers here on Ceres so that we can see them, and we'll back away here just a little bit to see they're widespread. So volcanic activity of a kind might be pretty common here on Ceres as well. Just remember that we're not talking about molten rocks anymore. But that doesn't mean we're done with molten rock volcanoes. There's still more lava in the outer solar system. And to see it, we're going to need to head out to Jupiter. Jupiter, certainly no volcanoes on that gas giant planet, but I've already shown you a couple of the moons that we are going to visit. And moons like Europa and Io are able to have geologic activity for a couple of reasons. First, it's their orbit around Jupiter. You can see Jupiter there. I've got the orbits of the 4 largest moons here. Io and Europa are the 2 closest on this view. And then there are 2 others, Ganymede and Callisto, that are on the screen for you as well. Now, so the first factor that helps some of these moons have geologic activity is that their orbits are not perfectly round. So I've got their orbits in white here. I've added red circles that are perfectly round, and if you look really carefully, if you are watching the video in full screen, you might be able to see that the orbits are not perfectly aligned with those red circles. It's especially obvious with Europa here, so I'm going to zoom in on its orbit just a little bit, and you may be able to see, even on my little view here, I can see that the orbit is inside the red circle on the left, outside the red circle on the right. So its orbit is not perfectly circular. So it's always changing its distance from that giant planet that it orbits. Then there are the other large moons nearby. All 4 of these moons exert gravitational pulls on each other. So they're changing distances from Jupiter, they're changing distances from each other, helps cause tides that stretch out these moons. Tides, like we think of tides here on the Earth with the Earth's water moving. Tides can affect the shape of a moon, even if it's just made of rock and ice. That's what happens here with these moons. It warms up the interior of the Galilean moons. That helps them have various forms of geologic activity. I'll show you the examples on Europa and Io very quickly. Europa, what we see here is an icy crust, but because the interior of the planet is warmed by these tides, I think that below this icy crust there's a vast global ocean. You can see some signs of this here on the crust of the moon. You can see those grooves going across it. That may be because of a type of tectonics going on here. The crust moving, the ice breaking, shifting, and then refreezing. To better understand the ocean, as well as possible changes on the crust, Europa is going to be targeted by multiple spacecraft in the coming decades. We've got the European JUICE mission and NASA's Europa Clipper mission, both scheduled to launch in the mid-2020s and making multiple flybys of Europa to better understand the activity there. But the real volcanic highlight of the Jupiter system, and really perhaps the solar system, is Io. Io may be the most actively volcanic world in our entire solar system, despite its relatively small size and its distance from the sun. A lot of the energy for these volcanic eruptions, again, going to be coming from gravitational tides from the planet Jupiter and the other large moons in orbit nearby. Scientists have been able to map dozens, hundreds of volcanoes erupting across the surface of Io. Other spacecraft have imaged plumes of active eruptions here on Io, and we can just track hot spots on the surface as well. Lava lakes and things like that all show that Io is a geologically active world. So we found some pretty good examples of volcanoes so far, but I'm not done yet. There are still more volcanoes to see. It's going to be tough to beat the sheer number of volcanoes that we have here on Io, but there are some that are perhaps a bit more photogenic. So let's head to another moon of a gas giant planet. Let's move out to Enceladus. Now, Enceladus is the smallest of the worlds that I have previewed for you so far. And we're going to need just a second to get out there. Software is going to do a quick little reset here for us. Enceladus is a relatively small moon of Saturn, and it's got another icy crust, kind of like we saw there for Europa, and it also has grooves going across it. Let's see if we can jump out there quickly and easily. I'm going to have to, since the computer reset for us here, we're going to head back to Venus real quickly, just get our stage set. And let's see how quickly we can find our way out to Enceladus. So bear with me just one moment. We are going to see if all this is enough to get us to Enceladus. All right. Enceladus is thought to also have a global ocean under its icy crust. But the real sight to see here, let's see if we can get those to activate, are vast plumes that are known to erupt from Europa's south pole. Should have those on the screen for you too. They're a little faint, a little hard to see, so let me get a little bit closer here. Might make them a little more interesting to look at. So these are vast plumes erupting from the south pole of this moon. We've mapped out over 100 of them, and they seem to be fairly continuous. I think there's always plumes of water vapor erupting from the south pole of Enceladus. Now, the story here is basically the same as it was at Jupiter. We've got a moon that is in a not perfectly circular orbit around a giant planet, so it's always feeling varying pulls of gravity from the planet that it orbits, and there are some other large moons not so far away that help add to the gravitational stresses and the tides that this moon feels, and so its interior is warmed, it melts below its icy crust, dust, and these giant plumes can erupt from its south pole. Now, when the Cassini spacecraft was here in orbit around Saturn, it flew by Enceladus multiple times. It made some flybys directly through the plumes and measured not just water vapor in the plumes, but also minerals that suggest there are hydrothermal vents on the ocean floor of Enceladus. So there are underwater volcanoes here on Enceladus. There's also material mixed into the water that could serve as food for microbes. So we have examples of that here on Earth as well. So all the ingredients for life seem to be available here on Enceladus because of those underwater volcanoes. Definitely an interesting world worth exploring. Hopefully another spacecraft will come out here someday and better map those volcanoes and study the nature of the subsurface ocean here on Enceladus. Pretty interesting place, and maybe one of the most photogenic places we'll visit during the show today. All right, still a little bit of time. So I had a couple more destinations planned for you here. And for these, we're going to travel even farther from the sun. We're going to check out two worlds where, if I had to guess without knowing what comes next, I would say that they formed so far from the sun that they should have always been frozen, never had any geologic activity of anything to speak of here. So that would make sense. But surprisingly, they're objects that form billions of miles from the sun that have temperatures colder than almost any other place in the solar system, but still have geologic activity. Again, the blue circle is the size of the Earth to give you a sense of scale. And then I've got Triton and Pluto here for you. Both of these worlds almost certainly formed in the outer reaches of the solar system, what we call the Kuiper Belt today. Now, Triton at some point got close enough to Neptune that it was captured by the planet's gravity. So it's a moon today, but it wasn't always the case. So these were probably both originally Kuiper Belt objects. Triton a little bit bigger than Pluto, so at one time would have been the largest Kuiper Belt object. But it got captured by Neptune. It has a not quite circular orbit around Neptune. So perhaps for that reason, just like we've seen for the other moons around those other gas giants, there are some signs of geologic activity at Triton as well. So let's go take a look. Triton, I don't have a whole lot of real pretty pictures of because it's only really been seen up close once. The Voyager 2 spacecraft flew by Triton here way back in 1989. And when it flew by, it saw things like this. Now, these are pictures from 1989, but it's a spacecraft launched in 1977 with even older cameras on board. So it's not crystal clear. But if you watch carefully at the center of this series of images, there's a dark streak that rises up and then takes a sharp bend over to the right. What planetary scientists are pretty sure that is a plume or something like a geyser. As erupting from the surface of Triton, actually gets bent over by winds in this moon's very thin atmosphere. And those plumes, as well as other signs of volcanic activity, are one reason why planetary scientists want to visit Triton again. It's been a little while. And so we've got more questions than answers about this moon. There's currently a mission being considered for launch in the next decade or so named Trident. Now, Trident would be another pretty quick flyby of the Neptune system, but it would focus on Triton specifically because of what was seen by Voyager 2 when it flew by. We've got the plumes, the geysers erupting from its surface. There are other signs of some ice movement, some tectonics on the surface of Triton, perhaps a subsurface ocean here, just like at Europa and Enceladus. And there's that atmosphere that I glossed over pretty quickly as well. Most moons in the solar system don't really have much of an atmosphere. Titan at Saturn has a really thick one, but Triton is also on that list of moons with atmospheres. So we want to understand what's going on here, and another flyby with more modern instruments would do a lot to help. So Trident is under consideration. It was announced as a finalist just earlier this year. So probably going to be a little more of a wait before we find out if Trident is destined for the Neptune system. Certainly hope it is. But even if we don't get to see Triton up close again, there are more places to go where we can find volcanoes and other geologic activity that happens all over the solar system. Let's make one more stop. Let's go take a look at everyone's favorite former planet. Let's go see Pluto again. So, Pluto, visited by the New Horizons spacecraft back in 2015. And that flyby revealed a number of interesting features. I've mentioned this atmosphere before, the giant nitrogen ice glacier, even possible cryovolcanoes, giant mountains like we saw on Mars, more like the volcanoes that we're used to here on the Earth. But because I've already shown you those features of Pluto in previous episodes, and if you haven't watched all the previous episodes, they're all in the video section here on Facebook. Let me show you something a little bit different. So let's see. Luckily, we approached exactly the right region here on Pluto. Over here to the west of Sputnik Planitia, that giant glacier you see at the bottom of your screen, there are some giant valleys, and these may again be rifts, sort of like we have seen on other worlds. These not necessarily related to volcanism, and they may be a result of the giant impact that may have formed that basin where the glacier is. But here, this one is named Virgil Fosse. And Virgil Fosse here may be a cryovolcanic vent. We have evidence of that thanks to images from the New Horizons spacecraft. Here's a close-up of this region. You see the canyon kind of stretching across the view here. A number of interesting features pointed out by the mission scientists, but this view is what really gives us away as a possible site of volcanism on Pluto. This is tracking where there is water on the surface of Pluto. And right along this vent, we see that there is more water than in regions farther away. So that suggests that perhaps there is a reservoir of water, liquid water, under the surface of Pluto. Just like at Ceres and the other icy moons, probably has to have some salt mixed in with it to help it stay liquid at the cold temperatures here on Pluto. But thanks to motions in the crust of Pluto, perhaps because of impacts or because of other sources of energy, perhaps the decay of radioactive elements inside Pluto, there's enough energy for the crust to be broken apart and moved, and there are vents that release some of that salty water from inside of Pluto, and it's been leaking out here on the surface, so it looks fresher right along this vent. So that's an interesting sign of what we may discover if we're able to get back out to Pluto and study it in more detail. A lot of planetary scientists have taken a close look at Pluto, think that there is a subsurface ocean here, which is pretty surprising given that Pluto is relatively small. Its surface temperature is approaching minus 400 degrees Fahrenheit. How could Pluto stay warm enough on the inside to have a liquid water ocean? Well, it may be because of an exotic form of ice. Some planetary scientists now think that under the crust of different ices that New Horizons was able to observe directly, the water ice, nitrogen ice, carbon monoxide ice, there may be a layer under the surface of Pluto that is a special form of ice crystal. It's called a clathrate. And in a clathrate, the water molecules are arranged kind of like cages, and they trap molecules of gas within them. So it forms kind of an insulating layer. And it's kind of like an insulated mug or insulated water bottle. It'll have a layer between the interior surface and the exterior surface is maybe filled with air, or something like that. It helps insulate the material inside, keep your drink at either the hot or cold temperature that you want. So if there's this layer of clathrate inside Pluto, that can help keep the interior warm enough with a little bit of help from some radioactive elements inside the dwarf planet. That could keep a liquid water ocean inside Pluto and might keep the inside warm enough to power some of this geologic activity we see on the surface of this little world. So there you go. Volcanism takes many forms throughout the solar system. Perhaps on Venus, it's a lot like on the Earth, maybe even more widespread on Venus than it is here on the Earth. But it's spread all throughout the solar system as well. Just about any solid world you might want to visit, you'll probably find signs of either current or past volcanic eruptions, other forms of volcanic activity, and geology shaping the surface of these other worlds. If this quick fly through of the solar system and its geologic processes inspired any questions, again, feel free to leave those in the comments here on this video. Always looking for your input to help plan future shows. If you have questions about other things out in space that you want to see in future shows, feel free to leave those in the comments as well. Always willing to let your input guide future editions of this show. Certainly we'll be back next week with more to see in the universe, doing these on Thursday afternoons, 2 p.m. Eastern. So tune in right here on Facebook once again to see more of what the solar system has to offer. Until next week, I'm Justin. I look forward to seeing you again, and stay safe. See you next time.